My boy Richard, he dropped an experimental video on LCMs. LLMs are getting replaced, it seems. I want to see the comments before we hop into this one. Meta's been killing it with this byte latency transformer. Yeah, I'm curious to see what you got, man. I found his post on Reddit, so I know this shit gonna be like,
So a few days ago, Meta released a new architecture, and they call it large concept models, language modeling in a sentence representation space. Bottom line is that these aren't transformer models. They do utilize a small portion of transformers, which we'll go into in a second, but these are not like any sort of transformers architecture that you've ever seen before. And this architecture is really cool. I've played around with it now at this point. I'm a big fan of it. That's why I'm showcasing it. If I weren't a fan of it, I probably wouldn't be making a video on it, just honestly. So very simplistically, there's a research paper. You can find the research paper. It's very straightforward. And then their
I'll explain the research paper in 5 seconds. Large language models use tokenomics. Tokenomics is what reward process you can train it off of. So if I say here is 5 tokenomics, the AI or LLM that I'm training will regurgitate whatever I need for 5 tokenomics. Large concept models is completely different. Ain't no tokenomics. It's basically a hallucination and a regular thought prompt combined into one to formulate and give you conceptualizations or predictions on what you might want. That's kind of like what we do on a daily basis, basically. If you tell me you hate me, I'm going to think that you a hater on the left side, which might not be true, and on the right side, I might think I did something wrong, which could have some truth to it. I combine those two things, and then you have thought. That's why this model is so cool because it's an upgrade from LLMs for sure.
paper outlines the framework for how to build this model out and their framework for building it out. They also release a few different models. And they scale it up to 7 billion parameters. So they release a few, like as far as I know, they released a 7 billion parameter model. I haven't seen the 1.6 billion parameter model as far as the weights, and I haven't played around with their trained models. So right, that's the thing. Like I can't find them, so I want to. So if anyone knows like where I can like play with their trained models, I would love to. But so
I'm done spending,
You tried Hugging Face? I mean, I've used Llama 3. It was actually Llama 3 I used to train my Jarvis system, which I am trying to learn before embarking on that journey again. But Hugging Face is a good platform. They got Quen, they got Llama 3, Mistral. They got all the latest and greatest LLM machines that you can test and train your models off of. They even got some image generation ones too. So like check out Hugging Face and just that overall library. And I would say go lock into the dev community. We be giving out like LLM tips or how to make your own LLMs. LCMs, I don't know. That's still new as Meta just released it. But LLMs for sure, game.
I took their architecture and I want to know how it works, right? So the very first thing I want to know is how does it work, and then can I make it better? And so that's kind of the like my mindset with a lot of these things, right? So like let me first understand how it works. Let me take it apart, and then when I put it back together, can I put it back together better than I found it? And that's kind of my goal, right? And then so looking at this, the very first thing that I do is I set up an experiment where I outline the base architecture, and then so outlining this base architecture, it's
For those who's viewing, yeah, I already know the drill. Take out your notepads, take out your notes, my little fellow scholars. If y'all don't got that, please leave. Yeah, you gotta pause, get your notebooks, get everything, cause we learning here. If you're not learning, turn the fuck around.
I outline looking at the found it, and that's kind of my goal, right? And then so looking at this, the very first thing that I do is I set up an experiment where I outline the base architecture, and then so outlining this base architecture, it's very cool, right? There's a lot of cool elements that are within this model, and then so straightforward off the top, there's a concept that is important to go into within.
I'm gonna have my notes on the top of the screen just in case. I'm not leaving a link below. If you ain't keeping it up, then that's on you, my boy. Link to the video will be in the
Neural
description.
networks that is very much at play within this model, and they do it in a very unique way, which is the architecture overall of this model. Like that's what I'm about to go into is defining everything that this model is, basically. And so within neural networks, you always have a linear process and then a probabilistic process, and or a probabilistic process and then a linear process. But it's always a combination of this linear and probabilistic process. And that's what essentially makes an LLM model, is that combination. And then so how this particular model works, this LCM model works, is uh, a unique play on that.
For those who don't know, we do linear process because that's just how the brain is structured. The brain is already structured to think linearly. Anything outside of that parameter causes chaos. That's why you oftentimes hear the monkey mind and all of them things. So the probabilistic process could be hallucinations or anything that is a result from the linear process that we're already going through right now. And this just goes back into NLP and just a whole deep network natural language processing model entirely. This morning I did an AI generation course in deep net learning. No, it's not up. It's behind a paywall.
So hyperbolic space is 3D digital space. And so all of the mechanisms that the model does, like what it does, is all linear, right? So it's all, you can see linear progression, right? So when we're defining this initialization, it's all linear. We can see self.linear, define forward self.linear,
Got
right?
that
So, and then
Office Google
everywhere you're
collabs right
seeing
there
here,
too.
you're seeing all of these linear equations. But then when you look at kind of what some of these things are doing, so we see that this maps input embeddings to the model's hidden dimension after normalization, and then this next one maps hidden state outputs back to embedding space with denormalization. And then we have a standard decoder only transformer. And then when we put all of that together, what this model is doing is it maps input embeddings to a hidden space. And then we have a transformer decoder, which autoregressively processes those embeddings, and then that maps output back to the embedding space.
What I will do is link his Google collab. I ain't trying to be fucked up, but hey, look, my job is not here to hold your hands. It's either you know it or you don't. But this Google collab one, it gives you insight on what, like, he did a good job at note taking. So you could kind of follow along with him throughout the video. So this first one right here, the map embedding, the input embeddings. Second class is the hidden states outputs. And the third one is the standard decoder only for the transformers. So if you can follow along with the video, that'll help you with your learning process so you could take notes.
Space. In simplistic terms, as simplistically as I can break this down, it's super cool how this works to me in that so it's all linear as far as the what the model is doing, linear progression, but then that probabilistic layer is a hidden space itself. Think of it like a box, right? And then so the model will do.
No, don't think of it like a box. I ain't going, don't, you gonna confuse people. Think of it like how you think. If someone says I hate you, right? You and that impulsive response is what's invisible. Your impulsive response is what's invisible right now. You might say F you too if you say that. If you do say that, that F you is that hidden response that you probably don't want to say out in public. That's the left side. That's not linear. The linear is the response you give to the public. So, like, I hate you. Why do you hate me? You feel me? That other response, which is like probably going to be disrespectful, something you might not want to say, that's the hidden response. That goes straight to the back of your head, and you might chuckle in person or chuckle with another person that you feel comfortable with sharing that hidden response with. You feel me?
Linear algebra, and it'll put it in a box, in a magic box, and then the box itself is the probabilistic aspect. It's the no one is looking into the box, right? So it's taking just pure advantage of quantum mechanics within this space, which is amazing to me, right? Like how I never thought about that, but so quantum mechanics. It's you're putting Schrodinger's box in digital space, and then you're putting a network weight inside of Schrodinger's box, and then that Schrodinger's box is your probabilistic mechanism for your linear layer of your model. I mean, it's beautiful. This is amazing and super cool, right? So understanding what that is doing within that to
Yo, you know what's funny? I was thinking about it, right? Imagine, and this is for all the people that's already jailbroke la large language model like Claude, OpenAI, Gemini, y'all know the list. Imagine that response, those prompts that we get is what LCM is. Because remember, all a jailbroken large language model is a remove of the constraints and the stuff that is supposed to be given to us, like that hidden area that he's talking about right now. Imagine that that aspect of jailbreaking is what is LCM, what is grandiosely new. Yeah, I want my money back if that's the truth.
me, it's very straightforward, right? And then the thing I should highlight is that it also, rather than taking in tokens and individualized words, it takes in sentences. So if you see here, I have this loaded here, this glove 6B, 300D, etc. This is a training set, a glove training set, so global vectors for word representation, put out by Stanford. And I just downloaded it straight from the website, right? Straight from the glove website. And these are word vectors that are already created of sentences. So they're just sentence vectors, right? And that's what I'm using for the training for all of this.
Can we stop with the self?
So he's using, and that's the thing about it. A lot of this LLM stuff is trained on public data. So it's gonna be like interesting to see
So we're
what
just
is public for us to use.
essentially mapping those embeddings and we're mapping the sentences as a whole. So no word tokens. It's we're mapping sentences and outputting sentences. And then we so that plus our hidden space rather than like a hidden layer like a hidden part of the neural network, it's a hidden box of the neural network. It's super cool to me. And then so
He's confusing y'all. Don't think of it as a box. Think, all right, there's a left side of the brain and a right side of the brain. If you take anything from it, just take the analogies that I'm giving you. You won't confuse the fuck out yourself if you keep thinking it's a box with things going in a box. Because you know why? AI, LLM is trying to replicate what humans do on a daily basis. You don't hear scientists compare us to fucking rocks, my nigga. They compare us to a living thing. They compare us to a living motherfucking thing, bro. Let's be real. Stop comparing AI to a box. That's all I gotta say.
that
It definitely ain't no motherfucking box. If it's a box, it's the smartest motherfucking box in the world. You hear how dumb, like, I ain't trying to come at him for the analogy, but you hear how, like nonsensical it could be at some point? It sounded smart at first to him, but like, he started the sentence by saying he wasn't even thinking of that. Duh, that's the whole point. We have people thinking of it for you.
that's putting it together, right? And then so okay, I understand how to put it together at that point. Let's start making it a little bit better, right? Like so, my first iteration is making it like a little bit better, and then so what I do is I just increase
What line is he on?
my knowledge. I take
Maps
what I
and that.
know about hyperbolic space and I do a few things. The very first thing I do is I add curvature to the space, right? So I create a Poincare ball, and then that's the shape of my neural network, which would be like a circle inside of a circle, is what it maps to when you map it to like a 2D
Yeah,
map. Is
yeah.
kind of what it looks like to me. And then, so I'm just creating that space, and then I put a little bit more math into that space. And then I do in my forward layer, I have a map back to Euclidean space as opposed to just keeping it within hyperbolic space. And then I have that curvature, right? So then I put in a little bit more math for the curvature. Everything else is pretty standard and straightforward between this model and the other one. Oh, and then
And I'm not gonna lie to you, you have a beautiful way of like problem solving. Like I'm going back and forth. I don't know how you got here, bro. And I kind of feel bad for coming at you for the analogy, but your skill. This is art right here. Keep on going.
I also add I do some updates to the attention mechanism. So I add cosine similarity for accuracy. I add noise to the environment to like kind of strengthen and make the embeddings more robust during the training mechanism. And then I have to test the training, right? So I want to test it and train overall. So that's what's added to this code. Those are the overall elements that I add and then I test. And then 100% accuracy. Look at that. After three epochs, and that loss rate, I like that. Like it's starting off at 1, which is good, and then it goes down to 0.86 within 5 epochs, which is marvelous. And then from 0 to 100 as far as that accuracy. So I really like
Epoch.
that, right? I don't like that
Is my epoch
fluctuating
is it have
accuracy.
a
So I want to
carbon
fix
thing?
that. But this is uh, cool, right? Like so. All right, my very first attempt at training this model, I just put like a few enhancements to it. Just going through knowing like I'm just gonna I know I'm going to do these things to it anyway, so I just do these as my initial test, as my initial baseline, and my initial baseline comes out
Oh,
super cool, right? So then it's
it
like, okay,
made
my
request to
next step,
access your
I
data
can
store.
recreate the model, I can put it back together, I can put it back together a little bit
Nah, that was smooth. I ain't gonna cap. That was smooth. That was smooth. I was about to see if your shit worked, but respectfully, I wouldn't want you to have my data on Google. I ain't gonna
better
cap.
before, and then I like to do like that MythBusters approach, right? Let me take it like to 9,000. Let me take it off the rails, and then can I do that? And then so that's what I start experimenting with here.
I hired an AI.
Nah, yeah, that was smooth. Let me see what the kind of great session. Keep up the good work. Yeah, that was smooth. Daddy's about to come in from creative mode. Nah, yeah, that was smooth. This nigga is
And
like,
then so that's when we go here, right? And so you're going to see uh, within this, what I do, what I've learned to play around within hyperbolic space that really works very well is to play around with geometry, all right? So to me, this concept of this
mm, can you, well,
hidden
hold on.
dimension within this network is
Dimension
the
values.
coolest part within this, right? So I decide, let me do something within this. And so that hidden dimension
Yo, you know what's crazy? I'm reading the description. You know how in like, well, I guess for agile development, right? You kind of got to test and unit test before everything gets pushed to production. So every smaller bit of code or every smaller bit of an assignment kind of gets tested. And then you kind of, it's not a waterfall method, it's kind of like a cycle, like the life cycle of a software development product. So, like, will this be a life cycle of an AI that we're creating, like the conceptual ideas, where like one small model gets trained on another small model, but it can't continue unless the small model is like able to accomplish all the parameters type shit? Like, yo, that sound like some sci-fi shit, low key.
dimension is a space, right? It's a dimension. And then it's a dimension within a hyperbolic space. And then so I say, okay, I want to take that space, I'm going to give it a shape. And the shape that I'm going to give it is very simplistically, it's a 3D space. So I'm going to make it a cube, but I want the cube made out of pyramids. And then so it's pyramids that will, stack together into a 3D cube. And then that's literally the space of this hidden space. So I'm giving the model in essence a fractal space, a fractal hidden box. So not
Yo, stop saying box, because you almost made me lose my shit, bro. So you know how, let me see if I could, because each spot of the brain has a hemisphere. Brain hemisphere, right? So this should be a good image. Hopefully it pulls up. All right, let me just pull that right here. All right, so the brain. So what he's saying is he created a box. I'm gonna just say a box because at this point this motherfucker fucked up my own version of how I thought. He created a box basically for analysis. That doesn't mean that he's complete. As you can see, this left side of the brain has a whole bunch of different shit. So a lot of different boxes in this sense will have to go in there to kind of hold it for, it's like a closet in this case. Everything that has to do with analysis will go in the analysis box. Everything that has to do with logic goes in the logic box. Idea, facts, math, you can keep going. What makes it cool though is I don't know if anyone's thinking like that, but each box kind of come together but they don't all work together at the same time. Like humans don't have 100% capacity to their brain. We need to dumb this motherfucker down to at least not some Lucy shit. You feel me? Anyone who's seen Lucy the movie, she got 80% of her brain, bro. Like Shorty could do whatever the fuck she want to a human. We not trying to create an artificial general intelligence like that, bro. So I guess that would be the only security measure. Like make sure he's like dumb. All these boxes that he's in can't be like 10 out of 10, bro. Like that's scary right there.
Not only is it Schrodinger's box, but it's now fractalized and it's now a 3D cube. And then it's a 3D fractal cube. And I say, here you go. Whatever you're doing probabilistically, do it in this box. And then, well, we're just, I don't know, like what all that's going to do, but it seems to me that that's going to do some pretty cool things. And then, so that's what I build out. And then we look here, and then as expected, I had to do a lot of tweaking, right? But so I go through, I tweak and refine, and then so this loss rate. So remember, our previous loss rate was starting off at 1.0. This is starting off 10 times less magnitude, right? 0.10. And then we go down by the end of it, 0.09 loss, which is, unheard of. Like you can't get to 0.0% loss because you have loss within the training data itself, right? So 0.000 across the board doesn't exist. 0.965, that's pretty close to zero. Like, or 0.0965, that's pretty close to zero. And then as you can see, 100% accuracy starting at 14 epochs, and it just goes straight through, right? So, this model at this point is benchmarking and clocking in performance metrics that you're not going to find within transformers. Just laying it out there, pure bottom line, right? And then so I just take it a step forward here. Let me try to take it off the rails even more. Let me add more stuff to it. Let me add more math. Let me test it very specifically with what we're talking about and what we're looking at here with these glove
I'm
embeddings,
trying to
which I
test
have
it.
loaded in.
I ain't gonna lie to you, Richard. I'm trying to test this motherfucker without you seeing my data. Yes, I'm taking that code, boy. You made it public for all of us to see, man. The link to his Google Colab notebook is right there. But what I'm not gonna do is let this video simmer out. And he might remove it soon. I ain't gonna lie to you, because this is a very detailed video early on about LCMs. Something that no one is doing right now, my nigga.
Here, and then we go through, and then same thing, right? I want to test it on real world data. I want to test it on sentences. Can I actually reproduce this, or was it an outlier? And then as we can see, it's not. It starts same exact thing with the glove data, the real data, right? Loss starts off at 0.10, exactly as it did, and then it goes down to 0.0941. It goes down lower in this instance by the end of the training and 100% accuracy. And then I also add, in this instance,
Well, each
I add another bell or
accuracy is
whistle to this model, which is a curvature adjustment. So as I mentioned before, I'm curving this hyperbolic space that this model is operating within, right? I'm creating that point care ball.
yeah, I'm gonna have to eat pop.
That's the outer layer, and then so it's essentially a curvature within the space, right? And then it's generally like about a 55-degree curvature, like 53 to 55-degree curvature. And then so I'm just saying within that, the model can self-adjust that curvature, and it does, right? It goes from up to down. It goes from 0.5414, and then it ends at 0.5453, and then so you can see it's ticking up. It ticks the curvature up every single time and every single epoch, and it continues.
Curvature. I ain't gonna lie to you, bro. I think that's one thing you said a lot of times. I just wanna like make sure. What does curvature mean, do, or insinuate when it comes to LCM and LLM? Explain like was 5 1 example, regular. Next example for a person that loves basketball. Yeah, I love basketball. It's gonna be easy for me to understand if you break it down like that. If y'all don't know what y'all like, your favorite things, yeah, have it break it down like that. It's gonna make sense like this. What does curvature mean? Curvature in context refers to bends, model, or adjust All right, the basketball analogy. Imagine you're dribbling the ball down the court, straight path, no curvature. It's like running straight to the hoop. No defense, easy shot. Curvature happens when the defense shows up and you need to cross over, spin, and change direction. Oh, curvature is how it navigates around a complex issue, right? Yeah, you could cross up the defend. More smoother the model can cross up the defenders. Okay, I get you. I get you. So
Picks
we
the
can.
curvature up every single time and every single epoch, and it continues.
I mean, that nigga getting his handles up. Hold on. I fuck with that. I fuck with that. I fuck with that. Mhm. Oh yeah, for sure. I fuck with that. Hold on. This is why you break it down in a like a language you could understand. Cause like I love basketball, bro. Like crossover. You telling me my large language model about a everybody that I try to, you know what I'm saying? Like you just gotta make programming fun for yourself, man. That's why a lot of people just don't know it. Y'all out here copying other programmers word for word, but you see how I do. I'm gonna copy your shit, but I'm gonna take it and make it mine. Hello. Hello. Wait, hold on. So I guess all the epochs then are the man, this is a great video.
To tick it up. So if I had let this run longer, it's going to continue to tick that curvature up. And then the model, it's built in that the model is self-adjusting this, right? It's not this code that I have here. It's not just saying tick up curvature, like it's saying control curvature. So if the model didn't want to tick it up, it wouldn't continue ticking it up. So it tells
So
me
if he
that there's
didn't want
more
to
play
cross over, he
that
wouldn't
I'm
have to
not, I
cross
still
over.
haven't played
I
around
get
with
you.
fully within this. And as far as controlling the curvature and then perhaps increasing the curvature to actually increase this model performance even more. So this model could be optimized
So,
far further than my simple and few experiments with
so when you increase
it, but it
curvature,
looks
I'm
really
guessing you
cool to play
adding
around with.
more
I am super
tools
excited for
or
this
more
model
complex
overall.
ways he could
It's
break it
really
down.
cool. That's why I'm making this video on LCM models. I'm a huge fan. Thank you, Meta. Like this is, I mean, super cool overall to play around with.
Nah, thank you, bro. Don't be thinking meta, bro. Don't be thinking meta. I'm telling you, them niggas gonna try to take your video right now and try to apply it. My English is bad. I'm tired, yo. But just try to apply it in a way that is like stealing your information and your hard-earned research. This is research right here, but take notes too, because this is what it means to be a programmer. Scavenging the web, making sure you do your research and steal from another person if you need to. People will say that it's open source code, but it's as open as you want it to be. Anyways, as you can see, all the code has been, I guess, put into my notes, I think. Yeah, all the code has been put into my notes. I'm gonna try to train this on a smaller model with other details and notes. But great video, Richard. Thank you. Thank you. Make sure y'all, I'm gonna like this video, leave a comment on it because he definitely did God's work. Thank you. All right, like, comment, subscribe. The notes is up there. I'm not leaving it in the description. What I will do is leave uh make sure I don't butcher your name. I will leave Richard's Google Colabs and everything that he has in the description if he still gives you access to it. So